powers are there, complicated powers. For example, we can have f of x is equals to x raised to x, f of x is equals to sine x raised to x. We can have f of x is equals to x plus 10 raised to 10 sine x raised to 9 divided by x minus 1 raised to 5. So how to find derivative of these functions when powers are complicated? Here power is x, here also power is x. Here you cannot use any previous rule directly. Can you use addition rule, subtraction rule, multiplication rule? You cannot use any rule because here there is no number. X is a variable. You cannot use a raised to x property. You cannot use x raised to n differentiation because here powers, x power is variable. It's not a number. So you cannot also use function inside function because there are two different functions. It is not composition rule. You cannot use rule number 5. And here you can try to use division rule and then multiplication rule, but it is complicated because it is raised to 10, raised to 9, raised to 5. So many multiplied. It becomes complicated. So in this situation, what you do is you take log on both the sides. Consider the first example. F of x is equals to x raised to x. You take log. Base is always e. So you take log on both the sides. What is the property of log? When term inside power is there, that power comes outside. That is the property of log. So now you are having log on both the sides. Taking log on both the sides. You have to write over here. You can write over here. Taking log on both sides. So now differentiating both sides with respect to x. With respect to x. And differentiation of, what is differentiation of log? It is 1 over whatever is inside multiplied by, what is differentiation of f? This is df dx. It is composition, rule number 5 is equals to, now two functions are multiplied, x is multiplied with log x, so you will use multiplication rule, right? This is differentiation of x log x, so this is multiplication rule, rule number 3. So this will be x derivative of log x plus log x derivative of x. So this dx becomes 1, this becomes, what derivative of log x? Derivative of log x is 1 by x plus log x. So this cancel, this is 1 plus log x. On this side you are having 1 over f of x df dx. That is what you want to find, na? df dx or dy dx or f dash x. That is what you want to find, derivative of f. We want to find derivative of f, na? So this is 1 plus log x multiplied with f of x. So this is 1 plus log x multiplied with x raised to x. That is your f of x, right? So this is your f dash of x. So just take log on both the sides. Now a second example also you can try to do as an exercise. Third example you will be using a lot of log properties. So third example, we have f of x is equals to x plus 10. What is the example? X plus 10 raised to 10 sine x raised to 9 and x minus 1 raised to 5. Correct? Okay. Now if you take a log on both the sides, you have log of x plus 10 raised to 10 sine x raised to 9 divided by x minus 1 raised to 5. Now whatever is multiplied, log separates it as addition. Log of sine x raised to 9 because it is multiplied, and whatever is divided becomes minus log of x minus 1 raised to 5. Because we are using the property log a into b is equals to log a plus log b, and we also have the property log a divided by b is equals to log a minus log b. So these properties log properties we will be using. So again, power property of log, that is log of a to some n, this is nothing but n times log a. We will be also using this property. So here we will have 10 times log of x plus 10 plus 9 times log of sin x minus 5 times log of x minus 1. So now we have log f x is equals to all of that. I can just shift it. Can I shift it? Okay, I guess I can shift it like this over here. I'll have to erase this. Okay, let's just erase this part, and then I can shift all of this. Okay, so what is this? This was log of 5x minus 1, log of x minus 1. Alright, so on this side you're having log of f of x, and on the right hand side you're having these things. Now I can differentiate both the sides. Now you will write differentiate both sides with respect to x. So what is differentiation of log? You will have 1 over f of x multiplied with f dash of x is equals to, it's rule number 5 that you are using, is equals to 10. What is the differentiation of log? Log is whatever is inside is brought down, then multiplied by differentiation of x plus 10. Differentiation of x plus 10 you can check, it is just 1 plus 9. What is differentiation of log? Whatever is inside is brought down. What is differentiation of sine? Cos x. First you will read log, then you will read sine. So accordingly go on differentiating. Minus 5 times, then you read log. What differentiation of log? 1 over whatever is inside, so x minus 1. Then differentiation of x minus 1, it is 1. You can check. You will use rule number 2, no? Differentiation of x minus 1, that is subtraction of two functions, so x minus 1. So what this becomes, 10 times x plus 10 plus 9 cos x sin x minus 5 x minus 1. And then on this side you are having f dash x divided by f of x. So what is your f dash x? F dash x, or you can also say dy dx, all notations, right? So this is 10 x plus 10 plus 9, this is cot x minus x minus 1 f of x. Whatever is divided on this side is brought up. So this is your final answer. F dash of x is equals to this. That is what you are finding the derivative of. So taking log on both the sides simplifies the work when you are playing with lot of complicated powers. So that is called as logarithmic differentiation. When you are playing with complicated powers, you make sure to take log on both the sides. So after that we have something called as implicit differentiation. We studied implicit differentiation. So in implicit differentiation you have expression in which x and y cannot be separated. Like whatever you have studied till now, you have studied like this, no? F of x is equals to sin x, that is y is equals to sin x, that is y is on one side, all x terms are on other side. You have also f of x is equals to x times log x. So again y is on one side, all y term is on one side, all x terms are on the other side. So till now what you have done, this is called as explicit. That is, explicit means you can write y and x explicitly. Now y in terms of x or x in terms of y. You can write it separately, y on one side, x on one side. So that is explicit. But now what you will be studying is implicit differentiation. So implicit means you can have an implicit term. For example, xy plus y square is equals to 10. Now can you separate x and y? Let's say I am taking out y common. Again I will have x plus y is equals to 10. Then y is equals to 10 divided by x plus y. Now I cannot separate. I am having y here also, y here also. I cannot separate. So if I cannot separate, how can I find dy dx? I want to find derivative of f. Derivative of f means what? Derivative of y, na? F of x and y, they are same. We write like this, na? F of x is equals to y. Derivative of f is nothing but derivative of y. So how to find derivative of y? How to find derivative? Consider this expression, xy plus y square is equals to 10. Just differentiate both sides with respect to x. Differentiate both sides with respect to x. So on this side you will have differentiation of xy plus y square, differentiation of 10. Oh, there was one more rule. There is rule number 6. I forgot to mention. Rule number 6 is differentiation of any constant multiplied with a function is nothing but that constant you can bring outside. So for example, you can have differentiation of 2 sin x. That 2 is brought outside and you have differentiation of sin x. So that is 2 times cos x. So that is your rule number 6. Any constant that is multiplied. That is your rule number 6. Okay. And the derivative of a constant, what is the understanding of this? When there is change in x, what is the change in 10? 10 is not going to change. Your f of x, here your f of x is equals to 10. It's not going to change, na? X is changing, x can go. What is f of 1? 10. F of 2, 10. F of negative 1 also 10. So there is going to be no change. So derivative of a constant is 0. On this side, first you will use rule number 1, that is addition rule. After that, over here you will be using multiplication rule. Over here you will be using multiplication rule. And over here also you can use multiplication rule. It is y into y. Right? What is y square? It is y into y, right? You can use multiplication rule. But I can also use power rule. First I am seeing it is squared. So squared means 2 times y, 1 power less. So this is 1. So that is the power rule, right? Multiplied by, because inside I am having y, inside it is not x. So I'll have to differentiate that also. Then I'll have dy dx. Inside if it was x, keep in mind there is a difference between this. What is the derivative of x square with respect to x? It is just 2x according to power rule. Because again inside I am having x, what is derivative of x? I'll just have dx. That is just 1. So that I am ignoring. But when I am having derivative of y square with respect to x, first I will have to do this. That is nothing but with respect to y. But since I am multiplying denominator with y, I'll have to multiply numerator also with y. Now I can apply power rule over here because my variables in denominator and numerator are same. So now this becomes dy, 2y multiplied by dy dx. That is the understanding. Now similarly, what if I tell you another example? Let's come back over here. What if I have derivative of sine y with respect to x? First, what is derivative of sine? It is cos. Can I write x? I cannot write x. I have to write y because it is sine y. Can I stop here? I cannot stop here because inside I am having y. So I'll have to find derivative of that also. It is basically rule number 5. Composition of function. So that is what you will be doing over here. So is equals to 0. So if you want, I'll write. Now I'll continue this. So we started from here and just rub all this off. So we started over here. Xy plus y square is equals to 10. We proved that it is an implicit equation because x and y cannot be separated. Then differentiating both the sides with respect to x. Correct? Differentiation of 10 is 0 because 10 is not going to change. Then we have addition rule first because it is added. After that, xy multiplication rule, these two boxes are same. And then differentiation of y square is 2y dot dy. Now this dx and dx can get cancelled. So my final expression is something like this: x times dy dx plus y plus 2y dy dx is equals to 0. Now take all the dy dx terms on one side. Dy dx. What is inside? X plus 2y. It is x and 2y plus this y. Correct? This y is also there, is equals to 0. So what is dy dx? Now this y I can take on the other side, becomes minus. Now this is multiplied, it comes and becomes, it divides on the other side. So this is my dy dx. Let's take few more examples to understand implicit differentiation. You can have xy plus sine of x square plus y square plus y again is equals to, let's say, sine x. Now differentiate both the sides. What is differentiation of xy? A multiplication rule, na? X times dy dx plus y times dx dx. Multiplication rule, correct? Plus, what is differentiation of this sine? Differentiation of sine, we know it is cos, but inside I'll have to write whatever is input of sine, multiplied by, what is differentiation of inside now? X square plus y square. You will use rule number 1. Differentiation of x square is 2x plus differentiation of y square is 2y dy dx plus, what is differentiation of y? Dy dx is equals to, what is differentiation of sin x? It is cos x. Now group all the dy dx terms on one side. Sorry, this is dx dx. Now this becomes cancelled. This is just 1. Dy dx is over here and over here. So what you do is, and also over here, group all the dy dx on one side and whatever is multiplied with it. Here I am having x, okay, and here I am having 2y multiplied with plus 2y multiplied with cos x square plus y square. And here what is dy dx multiplied with? It is just multiplied with 1, no? It is just 1 into, so plus 1. So this is all your dy dx terms. Now plus, you have your this y from here, then you have your cos x squared plus y squared multiplied with 2x, so 2x cos of x squared plus y squared, and that's it, is equals to cos x on the other side. So shift all these terms on the other side, so that will become cos x minus all these terms. So let's say I'll just put bracket like that, and then all these terms, let's say this is capital A, so that will just come and divide over here. So that is your dy dx. Another simple example that we can have, differentiation of sine of xy. First is differentiation of sine, that is cos, multiplied by differentiation of xy, that is x times dy dx plus y times dx dx. Multiplication rule, rule number 3. So this is cos of xy multiplied with x dy dx plus y. So derivative of sine of xy with respect to x. What you have found? You have found out derivative of sine of xy. So derivative of sine of xy is cos xy multiplied with x times dy dx plus y. So all of this is implicit differentiation. So here we found out derivative of sine xy. I can have something like this now, y square plus xy is equals to, let's say, equal to cos y. Now again here x and y cannot be separated. How to find derivative? Just differentiate both the sides. What is differentiation of y square? 2y multiplied by dy dx plus what is differentiation of xy? It is x times dy dx plus y. It is rule number 3, multiplication of functions. What is differentiation of cos y? What is differentiation of cos? Differentiation of cos is minus sin y multiplied by what is differentiation of y? Dy dx. You will be using rule number 5 because it is not cos x, it is cos y. So differentiation of cos y. Differentiation of cos y will be differentiation of first cos function and then y function. So if you want, I'll write the proof for this. You have differentiation of cos function. How is differentiation of cos function? First is differentiation of cos. It is simple. It is minus sin y because inside y, so here also I'll write y. But I cannot stop here because I have one more function, that is y function. If it was just cos x, then I can write minus sin x. But now it is cos y. So I'll have to differentiate y also. What is differentiation of y? It is just dy dx. So this is all about implicit differentiation. You have to group all the, now here you have to group all the dy dx terms on one side. So dy dx, here I am having 2y plus x plus y is equals to minus sin y dy dx. Now this minus sin y, if I bring on the other side, it will become positive. So this becomes plus x plus sin y. I am grouping all the dy dx terms on one side. And this y taking on the other side becomes minus y. So dy dx becomes minus y divided by 2y plus x plus sin y. So that is your implicit differentiation done. After that we have something called as parametric differentiation. Here what happens is your x, we have two variables x and we have y, correct? Now here your x is a function of t, that is x of t can be t plus 1 for example, and y of t let's say can be sin t. That is x is a function of t and y is also a function of t. But in question what they can ask is what is dy dx. Every time you have to find the value of dy dx. You say df dx, you say dy dx. You have to always find the value of dy dx. How will you find the value of dy dx here? What you can do is first you look at y is a function of t because you get input of t. Instead of t, let's say y of 0. This will be sine of 0. So this is 0. So y will be equal to 0 when t is equal to 0. Because I put t is equals to 0. Na? So when t is equals to 0, y is 0. So now what I will do is I will find a differentiation or derivative of y with respect to t. So that is nothing but derivative of sine t with respect to t. This is cos t. Simple, straightforward. Then I will find derivative of x with respect to t. This is derivative of t plus 1 with respect to t. Now I'll use rule number 1, addition, dt plus dt, d1 dt. So this is dy dt. I am finding dx dt. Now this is dt dt, this becomes 1 plus d1 dt, this becomes 0 because differentiation or derivative of a constant, it is 0. So this is 1. So dx dt is 1 and dy dt is equal to cos t. Okay, so now how to find dy dx? That is nothing but dy dt divided by dx dt. So what is dy dt? Cos t divided by dx dt, what is it? 1. So that is nothing but cos t. So dy dx is equals to cos t. That's it. That is your parametric differentiation. Parametric means x and y are having parameters. So here one parameter is t. X and y are depending on t. That is, given the value of t, you can get the value of x. Similarly, given the value of t, that is when t is equals to 0, y is equals to 0. And what is the value of x when t is equals to 0? Here x will be 1. So when t is equals to 0, y is equals to 0 and x is equals to 1. So x and y are depending on t. So how to find dy dx? You have to find dy dt and then find dx dt and then just divide it. So let's take one more example. Let's say x of t is equals to t square and then y of t is equals to, let's say, tan of e raised to t. Now what is dx dt? You will use power rule. This is 2t. Then what is dy dt? First differentiate tan function, that is sec square e raised to t. Then differentiate e raised to t, that is just e raised to t. Rule number 5. One function inside another function. Then what is dy dx? You just have to divide dy dt with 2t. So this is sec square e raised to t divided by 2t. That's it. That's the answer. So just get dy dt, find dx dt and divide it. That is your parametric differentiation. So after that, we have the topic differentiating with respect to another function. Differentiating. Now till now we have differentiated with respect to x, right? We have functions and then we have differentiated with respect to x. And in parametric case, we have differentiated with respect to t. Because y and x are functions of t. If you have value of t, you can get value of x, you can get value of y. But now we are going to see something different. Differentiating with respect to another function. Like for example, we have f of x is equals to sine x and g of x is equals to, let's say, x square. Now we want to find df dg. How to find this now? That is differentiation of f with respect to g. So that is nothing but differentiation of sine x with respect to x square. It is not with respect to x. With respect to x means what? Differentiation of sine with respect to x will just cos x. That is what we have studied. Differentiation of sine is cos x. That is like this. Differentiation of sine x with respect to x. This is cos x. That is what we have studied. Differentiation of sine x with respect to x is cos x. But now here differentiation of sine x with respect to x square. How to understand this? Again, it is simple. Differentiate f with respect to x, and that is sine x with respect to x. You get cos x. Then you differentiate g with respect to x, that is x square with respect to x. It's power rule. This is 2x. Now you divide df dx with dg dx. So how does this look? Df dx divided by dg dx. This is nothing but your df dg. So what is this? This is cos x divided by 2x. So your df dg is equals to cos x divided by 2. It is very similar to what you do in parametric equation. So differentiation of this is nothing but derivative of sine x with respect to x square. So derivative of sine x with respect to x square is cos x divided by 2x. So we can take another example. Let's say f of x is equals to e raised to x and g of x is equals to cos x. Now I want to find find derivative of e raised to x with respect to cos x. We know this. Derivative of e raised to x with respect to x is e raised to x. We know this. But we are supposed to find derivative of e raised to x with respect to cos x. This we have to find. This we don't know. This we have to find. How to find? First step is derivative of e raised to x with respect to x. Find it. Then divide it with derivative of cos x with respect to x. This is nothing but derivative of e raised to x with respect to cos x. Now what is derivative of e raised to x with respect to x? It is e raised to x divided by. What is derivative of cos x with respect to x? It is minus sin x. That's it. That is your answer. That is your answer. So derivative, when you want to find derivative of first function with respect to second function, just find the derivative of first function with respect to x divided by derivative of second function with respect to x. That's it. So if you want, the general formula is, if you want to find df with respect to dg, that is nothing but df dx divided by dg dx. That is the formula. Now it's all about practicing. You need to practice a lot. You need to understand all the 5 rules. 6th rule also is there. 6th rule is differentiation of k f of x. K is any number. That is nothing but that number comes outside and differentiation. So this is your rule number 6. So for example, I can have differentiation of 10 times x. What is this? This is 10 times dx dx. This is 10. So practice problems using all these 6 rules. Understand them. Understand what is logarithmic differentiation. When to use that. When you have a lot of powers. That time you use logarithmic differentiation. Implicit means what? X and y cannot be separated. So you have to go on differentiating both the sides. And difference, when there is y, you have to be careful. You have to differentiate y also. That is why you are having dy dx. After that, you studied parametric, and when x and y both are depending on t. When I give you value of t, then you can give me value of x and y. You can always pause the video, rewind the video, scroll back. You can check. After that, you studied differentiation of one function with respect to another function. So the formula I have written down over here. I'm just going to put star also. It's a very important formula. So that is the major part of your differentiation chapter. After that, very small topic you have. One small topic you have is higher order derivatives. Higher order derivative. What you studied was derivative, correct? What you studied is f dash x or df dx or dy dx. Now this is all first order derivative. Keep in mind, all this is called as first order derivative. That is, you are differentiating only one time, na? You are finding, for example, differentiation of sin x. It is cos x. That's it. You are stopping over there. But higher order derivative means you go on finding differentiation. That is, differentiation of sin x is equals to cos x. Again differentiate. Differentiation of cos x is equals to minus sin x. Again differentiate. So you go on differentiating. Now that is called as higher order. So can I say first order derivative of sin is cos, second order derivative of sin is minus sin. The way you will write it like this. So f dash, I'll write it step by step. So I'm having f of x is equals to sin x. Okay. F dash x is equals to cos x. F double dash x is equals to minus sin x. F triple dash x, again derivative. What is derivative of minus sin? That minus is a number, it's minus 1, na? So if you want, I'll write over here derivative of minus sin x with respect to x. So that is minus times derivative of sine x. That is nothing but minus cos x. So this is minus cos x. Again, fourth order derivative. That 4 is in Roman numeral. So this is minus cos x. So this will become minus will become positive. So this will be sine x again. So can you see that f of x is equals to sine x, but the fourth derivative also is sine x. You go on finding derivatives. So that is nothing but higher order derivative. In another notation, you can have like this: df dx, then d square f dx squared, then higher, this is second order, then third order you have d cube f dx cubed, and then so on. In terms of y, this notation you are having d square y dx squared, then you are having d cube y dy cubed, and so on. So that is your higher order derivative. Just go on differentiating. Now let's, for example, we have f of x is equals to x raised to 5. Now what is dy dx? Dy dx is power rule. Then what is d square y dx square? Differentiation of this, na, again you will differentiate. What is this? 5 will be outside. Differentiation of x raised to 4. This is rule number 6, that 5 is coming outside. It is multiplied. Constant is multiplied. So 5 into, now again power rule, 4x cube. So this becomes 20x cube. Then what is d cube y dx cube? This is dx cube. It is not d. There is a difference between this and this. There is a difference. Both of them are not same. Both of them are not equal. There is a difference between them. Be careful. So this is derivative of this. That is nothing but 20. Derivative of x cube again is 3x square. So this is 60x square. So can I say that which derivative? Third derivative. Third derivative of f is nothing but 60x square. So f of x is equals to 5, but the third derivative of f of x is 60x squared. You just have to go on finding derivative. The problem that happens in higher order derivatives is you cannot cancel the way you cancel in, that is in first order derivative. That is, you can have dy dx multiplied by dx dy, and then you can cancel this and say it is 1. But you cannot do this over here. Multiplied with d square x dy squared. Now you cannot cancel this. You cannot cancel this and this. This is wrong. You cannot cancel dx square and d square x. No, it is different. D square x and dx square are different. You cannot cancel. You cannot say this is equal to 1. It is not equal to 1. So you have to be careful about this. Because here you are having d square x and here you are having dx squared. In higher order derivatives, you cannot cancel. In first order derivative, you can cancel. Dy here dy and then here dx here dx. You can cancel, you can say it is 1. But in higher order derivatives, you have to be very careful. You cannot cancel like that. So one more example if you want of higher order derivative, we can have f of x is equals to e raised to x. What is the first derivative? F dash, it is e raised to x. Again derivative of that, it's going to be e raised to x only. So forever you go on doing, you take nth also, n times, 100 times you go on taking derivative. It is going to be e raised to x only. So nth order derivative, nth means whatever, let's say for example 10, n is equals to 10. So 10th order derivative also is going to be e raised to x only. So nth order derivative for this particular function is just e raised to x. So I'll give some assignments after this. This is the end only maybe one small topic, that is derivative of inverse function, that we will do later. But other than that, our differentiation chapter comes to an end over here. If there is any doubt, please scroll back. You can always re-watch, you can again listen. You can also contact me if you have any doubt. But you have to solve a lot of problems. You have to exercise, you have to solve the exercises, you have to read and understand the examples. You have to get speed in solving the problems. Differentiation is very simple if you practice. So I'll stop the video over here. Thanks for watching.